In this video, we're going to be solving some trig equations and some inequalities too. We're working through AP Pre-Cal Homework 8.1. So the first set of problems, we're going to be finding all the solutions just on the interval 0 to 2 pi. So we're not going to be looking for the general solution, just the one that's kind of the most obvious solutions. And the first one is sine x equals 1/2. And I'm going to work this one with a triangle and kind of using my preferred circle method. But I think the rest of these, I'll be working them with that circle method. So if we're saying sine x equals 1/2, okay, what we need to know is that like 1/2 root 3 over 2, these are 30, 60, 90 triangles, and root 2 over 2, that's, the type of output value that corresponds to a 45, 45, 90 triangle. So if we're talking about where sine equals 1/2, that's where the vertical leg of the triangle in standard position is a half. That wasn't very good. I think I can do a little better than that. Okay, it's going to be my hypotenuse. Vertical leg there is 1 over 2. That means this one needs to be root 3 over 2, and this will be 1. Okay, when you think about it, sine opposite over hypotenuse, that works. Okay, that's going to be a 30-degree angle across from the 1/2, so this is x equals pi over 6. Okay, but there's another place where sine x could be a half. It could be right there. It could be the same height over here. And there we go. Get ourselves another triangle. Okay, and that could be short of pi by pi over 6, and so that would be 5 pi over 6. Okay, now if we wanted to do that kind of like using a circle as our guide, what we need to remember is that on the unit circle, kind of the order that things go in is 0 is the least, then 1/2 is pretty close to 0, then there's root 2 over 2, root 3 over 2, and then 1 is the biggest of all. Okay, so if I'm talking about sine x equals 1/2, I'm going to go say, okay, sine corresponds to the vertical distance from the y-axis. 1/2 is not very far. Okay, so that's what I'm going to say, 1/2 right there. And I'm going to go side to side and, get the 2 points that have that y-coordinate of 1/2. And that's going to be pi over 6 and 5 pi over 6. And yeah, I drew those definitely a little bit exaggerated, but we know they're not actually 0 or pi. Okay, that's not where sine x would be a half, so it's got to be up above. But if I draw it like a little bit exaggerated, then I can tell that it's definitely not pi over 4 or pi over 3. It's going to be pi over 6 and 5 pi over 6. All right, for cosine x equals 1/2, okay, cosine is the horizontal displacement from the y-axis, so I'm going to go, and again, 1/2, that's not very far. So I'm going to go over here, let's say, right there. I'm going to go and look for a point on the circle that has this x coordinate, and so I'll find 1 here and 1 there. And so this would be pi over 3, 60 degrees up. And the other one would be negative pi over 3, but we're looking for solutions between 0 and 2 pi, so that'll be 5 pi divided by 3, short of 2 pi by pi over 3. And, you could also think about this, let me clear that, a little bit of that work out. We could also think about this, in terms of building up the triangle. That was maybe a little more than I wanted to erase. In terms of building a triangle, we could have said, okay, well, if the horizontal leg is a half, and that's not very big, well, we could have drawn our triangle like that. We could have seen it was a tall 30, 60, 90, which means that's a 60-degree reference angle. So that's how I know it's pi over 3. Okay, now this next one, we're going to have to do a little bit of work first. We're going to need to start by isolating the trig function. So we need to isolate that cosine x. So first we'll get rid of that square root of 3. I'll say 4 cosine x equals negative 2 square root of 3, because I have negative square root of 3, and I'm going to subtract another square root of 3. Then I'll divide both sides by 4. And I'll get negative 2 over 4 is negative 1/2 of the square root of 3. That's not a good way to write that, though, and we're more familiar with negative root 3 over 2. Okay, now root 3 over 2, that's pretty far over on the unit circle. That's almost all the way to 1. So I'm going to draw it that way. Okay, so negative root 3 over 2. Cosine is the horizontal displacement, so I'm going to go left root 3 over 2, which I think is about there. And I'll just go kind of looking for solution here or there. And there I'll have it, and that's going to be 5 pi over 6, just short by 30 degrees. Or beyond pi by 30 degrees, that would be 7 pi over 6. And, I think basically, you know it's going to be one of the unit circle values because that's like how these are going. We're not using a calculator, and that's the only way we're going to be able to do it. But also, you know, seeing that root 3 over 2, that's a 30, 60, 90 number, and if the cosine is a root 3 over 2, that's the long leg is in the x direction or the horizontal direction. That means it's going to be a 30-degree reference angle. Now the next one, I'm going to do the same thing, work to isolate the cosecant x, and then I'll want to turn it into sine using that identity. So first I'm going to add 4 to both sides. So 5 cosecant x equals 10. And then I'm going to divide both sides by 5, and cosecant x will equal 10 divided by 5, which is 2. Okay. We need to know that cosecant theta is 1 over sine theta so that we can, you know, put this kind of in terms of what we know. 1 over sine x is equal to 2, so that means that sine x has to equal a half. And now we can go to the circle. Once we get it to be, you know, trig function equals number, then we can kind of consult with the circle. Okay, so sine is a half. Okay, a half in the vertical direction might be right here. I think we may have already solved this one. I'm going to go over to the side and look, there's a point over here. There's going to be another point over here. That'll be pi over 6 and 5 pi over 6. Let's report those. Okay. All right, now the next one is tangent x equals 3, and I'll be honest, I'm still not totally sure how I want to like suggest you work these ones with tangent in them. On one hand, I could show you a similar chart, and it'd pretty much be like that. That's the equivalent of the yellow thing that I usually show you, and the yellow thing is kind of like the order of the values of sine as you start moving through the unit circle. These would be the same values of tangent. I don't think that's probably the way to go, though. I think I've got something a little bit better that I think is more natural. So what I need you to know is that tangent x is sine x divided by cosine x. So I'm going to go over here and write that. Okay, that wasn't the strictest fraction ever, but it's all right. What I'm saying here is that, well, like I think you've hopefully done enough unit circle practice that you know like how it happens that tangent x equals square root of 3. You've taken, say, the tangent of, what's the answer going to end up being? It's going to be pi over 3. You've taken the tangent of pi over 3 before, and you know that it ends up being root 3 over 2 divided by 1 over 2. And I kind of like this because like this is giving us two pieces of information. Sine x needs to be root 3 over 2, and cosine x needs to be a half. So I need to be farther up than I am over to the right, and so that would be right here. And that's going to be pi over 3. Now it could also be the case that it's negative over negative, and that'll give me that spot exactly across the unit circle down here at 4 pi over 3. But that's what we were seeing in the lesson, that solutions to these tangent equations are always separated by pi radians. And as a result, if we're looking for the general solution, we can just find one of them and add pi n. Okay, but this is not one of those situations. We're just looking for the values of x to make the equation true on the interval 0 to 2 pi. So I want x equals pi over 3 and also 4 pi over 3. Right, this one also looks like it's going to require some solving, so I'm going to try to isolate that cosine. So I'm going to start by subtracting 5. So I'll have square root of 2 times cosine x equaling negative 1. Then I'll have cosine x equaling negative 1 over the square root of 2. And if you're like, that doesn't look familiar, like a unit circle value, well, then you should probably rationalize the denominator. Negative root 2 divided by 2. Okay, and then, once I've got it down to trig value, or trig function equals number, okay, cosine x equals negative root 2 over 2, now I go to the circle. Okay, so if cosine is negative, that's where the horizontal displacement from the y-axis is negative. I'm to the left of the y-axis. I'm in the second or third quadrant. And root 2 over 2, that's what we get at 45, 45, 90 triangles, so I'm thinking here and there. Okay. And so that would be 3 pi over 4 and 5 pi over 4. And again, I think it's one of those things where you just are going to have to know that root 2 over 2 corresponds to a 45, 45, 90 triangle, which only happens at the pi's over 4. And then we can use the signs because we know that both the x and y coordinate on the unit circle of these pi over 4 points, they're some kind of root 2 over 2, whether it's positive or negative. So 3 pi over 4 and 5 pi divided by 4. All right, now we've got another one with tangent. So first I'm going to work to reduce the tangent, or reduce it now to tangent x equals some number. So I'm going to add 6, so 4 tangent x equals negative 4. I'll divide both sides by 4. Tangent x equals negative 4 over 4, that's going to be negative 1. All right, so that means that sine x over cosine x equals negative 1. Okay, now this one I don't think that we need to like write it as a fraction and be like, oh, okay, sines, but you know, actually, why not? I think this is juvenile, but I actually think it's kind of nice. One option is that sine is negative 1. Oh, no, that's not an option. Sine can't equal negative 1, while cosine is also equal to 1. They'd be equal, and it's because they're both equal to root 2 over 2. So I actually don't think that's the way to go anymore. Just think about the legs. Just think about the legs of the triangle. Okay, they got to be the same in length, but the negatives of each other. So that would be, you know, like here and there. Okay, where one of the legs is positive and one of the legs is negative, but they've got the same length. Okay, so that would be one of those 45, 45, 90 triangles. This is 3 pi over 4 again, and this one's 7 pi over 4. And so sin x equals 3 pi divided by 4, and also 7 pi divided by 4. Okay, now the last of these, just solve it on the interval 0 to 2 pi, and I think this is good. Like, seems like a lot, but we need that practice. So if I've got something like this, a fraction, I'm going to need to get rid of that 2 first. So I think I'm going to multiply both sides by 2, and I'll get cosecant x plus 3. Maybe I'll throw some parentheses around that. It'll look a little better. Equals 2 times 1 is going to be 2. I'll subtract 3 from both sides. Get cosecant x equals negative 1. Okay, remember cosecant is 1 over sine, so 1 over sine x equals negative 1. And I could flip both sides of this equation and get sine x equals negative 1, or 1 over negative 1, either way, negative 1. And, okay, sine is negative 1, okay, vertical displacement all the way as far as it can go down here at the bottom. That's only going to be x equals 3 pi over 2. So in the next set of problems, we're just going to be finding the intersections of various functions, f and g. And so we'll just start by, you know, if we want to find the intersection points, we're going to set the two equations equal to each other and solve for x. And so that'll be f of x equals g of x. And that would be happening when 4 sine squared x was equal to 1. And so I'm going to try to get the sine x on its own, because I like trig function equals number. Okay, and so I've got that sine squared x equaling 1/4. Okay, well, sine squared x, that means sine of x, you know, take the sine and then square it. So I'm going to say sine of x quantity squared equals 1/4, at least probably for this entire video, and maybe even like this whole unit till we're used to that notation. Okay, but now I'm going to take the square root of both sides, and when I take the square root of both sides, I'm going to need to remember to bring in that plus or minus. And then, you know, the square root of 1/4, I don't know if that like immediately jumps out to you as a number you need to know. If it doesn't, then what you can do is split it up, square root of 1 over the square root of 4, and then you should see, okay, well, the square root of 1 is 1, square root of 4 is 2. I'm going to have sine of x equals plus or minus a half. Okay, now that I've got it down to trig function equals number, or numbers, I can go to the circle. I'm going to say, all right, that's not the best one I've ever drawn, but sine is the vertical displacement. 1/2 is not very far, so I'm going to draw it like, you know, up here. Okay, I go side to side. I find these points. Okay, that's going to be x equaling pi over 6, and also x equaling 5 pi over 6. And I think that we're looking for the x-coordinate of the intersections for these functions. Yeah, but on this one, it would be easy enough to find the y-coordinate of the point of intersection because g of x is constantly 1. So, it's got to be 1. Next one is 4 cosine squared x plus 5 equals 8. So I'm going to set the two things equal to each other. And I'm going to try to solve for cosine x. Okay, try to get that cosine on its own on one side of the equation. So I'm going to subtract 5. Then I'm going to divide by 4. I've got cosine squared x, and I'm going to rewrite that as cosine of x squared because I really want to drive that home to y'all. That's what that means. I don't want there to be any confusion next year. And also writing it this way will be better for us next year too in calculus. It's overall better, I think. It's just not what you commonly see in the textbooks and stuff. So we're going to take the square root of both sides, and that's plus or minus the square root of 3/4. And we might need to do a little bit of simplification on that. That's going to be plus or minus the square root of 3 over the square root of 4, which is root 3 over 2. And I'm seeing that's an error, but okay, let me bring that grid back, or that unit circle back in. That's going to be a square root of 4. Okay, now that if I've got cosine x equaling positive or negative square root of 3 over 2, okay, well, I go over to, on the horizontal axis, root 3 over 2 positively or negatively, and then I go, search for graph. Okay, so it'll be here or there, here or there. Oh, whoops. There we go. That looks all right. That's as good as I've got. And so if cosine is root 3 over 2, okay, that's pretty far over. And I feel like I might have something might be off about this circle because these points don't look as extreme as I want them to. Let me try that again. Yeah, there we can tell if it's going to be a 30, 60, 90 triangle, and we were to draw the actual triangle in, we could tell it would be a shorter triangle and not like one with a 60-degree reference angle. So we know these are pi's over 6. So I'm going to have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And those will be my x-coordinates of my intersection. With this one, I'm just going to keep doing the same thing, set f equal to g, kind of plug in their expressions, solve for cosine x in this case, so 20 cosine squared x is going to equal 10 when I add 3 to both sides. I'm going to need to divide both sides by 20, so that'll give me that 1/2, and then, okay, we're not looking for where cosine equals 1/2, we're looking for where cosine squared is 1/2. So, I'm going to rewrite it as cosine x squared, then I'm going to take the square root of both sides. Okay, now the square root of 1/2, if you're remembering that's the same as root 2 over 2, good for you. If not, we're going to just go and kind of say, all right, the square root of 1 is 1. We know that. Divided by the square root of 2, and then we could rationalize the denominator, multiply by root 2 over root 2, which I think I've already done in this video, and that's going to give us root 2 over 2. Okay. Then I'm going to say, okay, now I've got it down to trig function equals number. I've got cosine x equals plus or minus root 2 over 2. So I'm ready to go to the circle. Go right here, and I'm going to say, all right, well, cosine is, well, any of the root 2 over 2's. Okay, well, cosine could be positive root 2 over 2 and be these 45-degree reference angles. Cosine could be negative root 2 over 2 and be these 45-degree reference angles. So that's going to be pi divided by 4, 3 pi divided by 4, 5 pi divided by 4, and 7 pi divided by 4. And so I'll just report my findings here. X equals all the pi's over 4. And this last one, now I like this last one because something a little different is going to happen on it. So we're just going to kind of, same as always, set the two equal to each other. Say f equals g. And then, so 2 sine squared x plus 1 will equal 0. And we just kind of start solving at that sine x, subtract the 1, divide by 2, maybe rewrite as sine of x squared equals negative 1/2. And maybe at this point you're like, wait a second, this isn't quite right, because I'm going to have to take the square root of a negative number. That's going to give me something imaginary. And, imaginary numbers are not outputs in this class. Okay, that's kind of what I would say. Nor are they going to be theta values or, values of x on the unit circle. So in this case, if I'm going to take sine of x and square it, I'm going to get a positive number. So this equation is going to have no solution. And my reason is that sine of x squared, like I said, is greater than or equal to 0 for all x, or at least the types of x that we work with in this class. So now we are going to solve some equations and write expressions for all possible solutions. That's the general solution. So this first one is 4 cosine of x divided by 3. So we're going to have multiple argument in here as well. I was kind of wondering when that was going to come up. Plus the square root of 3 equals negative root 3. So we kind of solved one similar to this. We're going to start by subtracting square root of 3. And we'll have 4 cosine of x divided by 3 equals negative 2 square roots of 3. I'll divide both sides by 4 and have cosine of x divided by 3 equaling negative 2 root 3 over 4 is the same as negative root 3 over 2. Okay, and now that I've got cosine equals negative root 3 over 2, that's definitely a unit circle value. I'm going to go over here to the circle itself and try to figure out where that's happening. So negative root 3 over 2, that's pretty far over, almost all the way over, right? That's very far. So I'm going to just look for points on the unit circle that correspond to that x level, because that's what cosine is, the horizontal displacement from the y-axis. So I'm going to go and look for circle, and that's going to be 5 pi over 6 and 7 pi over 6. So yeah, these are the angles that are going to give me negative root 3 over 2. And also, since we're looking for the general solution, it'll be 5 pi over 6 plus 2 pi n and 7 pi over 6 plus 2 pi n. So we're going to say, all right, this x divided by 3 number is equal to 2 pi over, or no, not 2 pi over 3, 5 pi over 6 plus 2 pi n, where n is an integer. Or, possibly from the other place we saw in the circle, x divided by 3 equals 7 pi divided by 6 plus 2 pi n. I think I'm going to move that. Yeah, I like that better. So I'm going to solve both of these equations for x by multiplying both sides by 3. So I'll have 5 pi over 2 plus 2 pi n, and also x equaling 7 pi over 2 plus 2 pi n. Now, I'm just going to say right now, I recognize that I think you might be able to condense these into like one singular expression, but that won't be necessary in AP Pre-Cal. They're not like really going to be testing on how well you can collapse these expressions for all the sets of all trigonometric solutions to all solutions to these trigonometric equations. I think that's how you would see the answer displayed if that's what they were asking for. Okay, now this next one, I've got sine of 4 theta plus 5 equals 11 halves. And so what I'm going to do, I'm going to rewrite the 5 as 10 halves. And to make it a little easier on myself to see what's happening here, do the subtraction, all that stuff. So I'm going to say, all right, well, I'm going to subtract 10 over 2 from 11 over 2, and I'm going to get 1 over 2. Sine of 4 theta equals a half. That's the type of thing I can do on the unit circle. So sine is a half. That's not very far up the unit circle. We look for a point. We're going to have one here, and we're going to have one there. Okay, so that's going to be pi over 6 and 5 pi over 6. And so that's what 4 theta needs to equal. So either 4 theta is going to equal pi over 6, really any angle coterminal to pi over 6, or maybe 4 theta is going to equal 5 pi over 6, or any angle coterminal to 5 pi over 6. Then I can solve for theta by saying, all right, theta is equal to divide everything by 4. So pi over 6 divided by 4, that's going to be pi over 24. And then 2 pi n divided by 4, okay, 2 divided by 4, that's 1 half. That's pi over 2n. Same thing over here. I'll have 5 pi over 24 plus pi over 2n. Here we've got another tangent equation. And so I guess first I'm going to start by solving for the tangent, but basically subtract the 3 square root of 3's. So if I have 2 root 3 and I subtract 3 root 3, I will be left with negative 1 root 3. Okay. And if you know that square root of 3 is, going to correspond to a 60-degree reference angle, good for you, go straight to the circle. If you don't, rewrite tangent as sine over cosine. Okay. And remember that you get the square root of 3 on the unit circle for tangent when you're taking root 3 over 2 divided by half. That's how it always worked. So I'm just going to say, with no loss of generality, that I'm just going to have the negative on top. Got a point there too. So I'm going to say, all right, well, suppose maybe it's, sine is negative and cosine's positive. And sine is more negative than cosine is positive because root 3 over 2, that corresponds to the long leg. So it'll be down here. So yeah, that should be good. And we'll go up here to the, well, maybe I can, okay, that's just getting worse. But that's, actually, let me try to fix that. There we go, that's much better. So this is a picture of a 30, 60, 90 triangle where the sine is, or the vertical leg is negative root 3 over 2, and the horizontal leg is positive 1/2. Okay, so that's going to be 60 degrees below the x-axis. So, you could call that 5 pi over 3 if you wanted, but if we're looking for all solutions, what we could say is, okay, one of these, this one corresponds to negative pi over 3. That's what I'm saying. Okay, but there's another one that's up here, and it's separated by pi, and I'm not sure if that's quite long enough to still be considered the same length as the other triangle, but that's not really my point. You see we got another 60-degree reference angle triangle there, and if we could have, what if we had the 1/2 being negative and the root 3 over 2 being positive? Then we'd be up there at 2 pi over 3. So you could say negative pi over 3 plus pi n, or 2 pi over 3 plus pi n. Either way, we're going to have this pi over 2x equaling something plus pi n. Okay, pi, because the period of tangent is pi. Then I'm going to solve for x by multiplying both sides by 2 and dividing by pi. So I'm going to have x equaling, with the 2 pi over 3, when I divide by pi, the pi's will go away. When I multiply by 2, I'll have 4/3. And then with the pi, I'm going to multiply by 2 and divide by pi. So I'll have plus 2n, where n is just some integer. With this equation, we're just going to kind of approach it the same way we have the rest of them. The fact that it's cosecant, we'll just isolate that cosecant and then turn it into 1 over sine, and we'll just go from there. So I'm going to start by subtracting 3 from both sides. So I'll have 5 cosecant 4 pi theta equaling negative 10. Then I'll divide both sides by 5. I'll have cosecant of 4 pi theta equals negative 2. Okay, but, we're not experts on cosecant, so we want to write this in terms of sine. And cosecant is 1 over sine, so I think that would mean sine is 1 over cosecant. So I'll say that sine of 4 pi theta is negative 1/2. And now that I've got it down to trig function equals number, I can go to the circle and say, all right, sine equaling negative 1/2. Okay, negative 1/2, not very far down the unit circle. I know that's like really not even all that close to a half. But in order for it to be obvious, what point on the unit circle we're looking for, you need to exaggerate. Okay, so I just want this to be as easy as possible for you. So that's going to be a little bit beyond pi. That's 7 pi over 6. Or a little bit before 2 pi. But maybe I'd call that negative pi over 6. Okay, because we can do that. We're looking for all solutions, so we don't really have to be too particular, just any of them, and then we'll add on 2 pi n. So either 4 pi theta is going to equal 7 pi divided by 6, or maybe 4 plus 2 pi n, or 4 pi theta is going to equal negative pi over 6 plus 2 pi n. And I'm going to divide, I'm going to divide by 4 and pi. So I'll have, all right, if I divide by 4, I'd have 24 in the denominator, at least the fraction 7 pi over 6, and divide by pi, I'll lose that. I think it's just going to be 7 over 24, plus, if I divide by 4 pi, that would be 1/2 n. Okay, that's kind of strange solutions, but we can work with that, right? theta equals, divide by 4 pi, that'll be negative 1 over 24 plus 1 half n. Okay, whatever. Next, we've got some inequalities, and we're going to have to solve these with circles. I really don't know how else you would. I think that's going to be the easiest and maybe the only feasible way for us to solve these. But if we just think about it in terms of circles, it's really not too bad. Okay, what I'm going to recommend is that we think about first, where is sine x equal to root 3 over 2 on the circle? So root 3 over 2 is really close to 1 up there. It's pretty high up. So I'm going to go over, I'm going to search for some graph. It'll be here and maybe there. Okay, well, close. All right, what I'm saying is it's going to be pi over 3 and 2 pi over 3. Okay, and remember, sine is representing the vertical distance from the x-axis. So when is that vertical distance less than root 3 over 2? Well, any time on the circle through here. And so I'm just going to say, okay, and you don't need to watch me color. There. So if we're looking for only values of theta or x on the interval 0 to 2 pi, we will kind of need to like cut off our solution right there. So if it's strictly less than, then we'll also want to exclude that value. Maybe I'll just kind of put the circle right there, right there. So it'll be 0 is less than or equal to theta, or I guess x in this case, which is less than pi over 3. And then also 2 pi over 3 is going to be less than x, which is going to be less than or equal to 2 pi. Okay, so that first inequality got me, that portion of it, and the second inequality got me the rest. All right, with cosine of theta less than less than root 3 over 2, I'm going to start where cosine equals root 3 over 2, and so it's going to be over here, almost all the way over to 1. So I'm going to search for some points on the unit circle. Go down here and get myself a couple. Okay, those are going to be corresponding to 30-degree reference angles, it looks like. And where cosine is less than root 3 over 2, again, that's going to be almost always. Okay, so I would call this pi over 6. And I'll be honest, I kind of think of that as negative pi over 6, but I can think about it, and it's short of 2 pi by pi over 6, so that's going to be 11 pi over 6. And so theta is going to be between, and again, this was a strict inequality. Cosine of theta was strictly less than root 3 over 2. So I'm going to say pi over 6 is less than theta, which is less than 11 pi over 6. Okay, now we got some compound inequalities. And I kind of wish we had one that was just sine and cosine first, but there was one like that in the notes. And so, you've seen it before. We're looking for where these things overlap. But tangent, I did not put any tangent inequalities in the notes. I didn't know we were going to need to contend with that. That's going to be a little bit more complicated. So I think I'm going to start by showing you where tangent equals 1. I'm going to deal with that in red. Okay, tangent equals 1 where sine equals cosine. That's at pi over 4. It also is one where sine and cosine are equally negative. Down there it's 5 pi over 4. And, they're supposed to be across the circle from each other. But right over here at theta equals pi over 2, tangent has that discontinuity. It has that vertical asymptote. So what's happening is, I don't know if I've talked to in my class about this. As theta approaches pi over 2, so maybe think about that red dot going up the circle. The y-coordinate is approaching 1, and the x-coordinate is approaching 0. So tangent is approaching 1 over 0. So like the numerator is getting bigger, and the denominator is getting closer to 0, and that fraction is getting like really, really big. And that's why we have that vertical asymptote. I think maybe in the last unit I could have just left it at, or divided by 0, and that's what causes the vertical asymptote. But it's going to go, tangent's going to go up to infinity as theta approaches pi over 2. And so, but then it's going to pick up at negative infinity and, resume increasing. I'll even sketch you a graph. All right, so there you kind of see what I'm saying, right? At pi over 2 right there. Okay, it approaches infinity, but then after pi over 2, it's kind of coming up from negative infinity. So tangent of theta is going to be greater than 1 through here, and then also through there. That's a little bit tricky. Hopefully we won't see too many tangent inequalities moving forward. I know that's probably not something we're going to be really seeing on like the unit test or the AP exam or anything. Cosine of theta is greater than negative 1/2. Okay, well, I'm going to go to where cosine is equal negative 1/2, and that's really not very far over on the unit circle. Okay, so I go and I look for points on the unit circle here and there. And if cosine is greater than that, I'm looking for all of the spots to the right of that on the unit circle. Okay, that part as well, all the way through here. And so really what I'm looking for is where I've colored on both. So I'm looking for the overlap. And so there was a little bit right here. And so that was between pi over 4 and pi over 2. Okay, now tangent of theta is greater than or equal to 1. So I'm allowed to equal pi over 4. So pi over 4 is less than or equal to theta, which has to be less than pi over 2 because of the vertical asymptote. And then also there's a little bit of overlap right down there. So that's going to be 4 pi over 3 up to 3 pi over 2. And we will be able to equal 4 pi over 3. Wait, no, that's where we won't be, because up there, if I plug 4 pi over 3 in there, that's not true, because cosine of 4 pi over 3 is equal to negative 1/2. So, okay, I've got all of that, and I'm going to say, all right, that interval and also 4 pi over 3 is less than theta is less than 3 pi over 2. And it has to be less than 3 pi over 2 because tangent of 3 pi over 2 is undefined. All right, cool. So we've got secant x less than 2 and cosecant x greater than negative 2. Okay, now, one thing, I think we have run into this in this class already. If we flip both sides of an inequality, we will need to flip the direction of the inequality. I think that actually should make sense with like this secant x is less than 2. That would be only if cosine x was greater than 1/2. Okay, because that's, 1 over this number is going to have to be, whatever. However you're going to think about it. And then cosecant x, I'm going to flip that and make it sine x is less than negative 1/2. All right, so I'm just going to go and kind of graph these individually. Cosine equaling 1/2 would be about there. It's going to be here and there on the unit circle, and greater than 1/2 is going to be on the outside here. Okay. Then sine of x is less than negative 1/2. Okay, I'll go and mark off what I think negative 1/2 is on the unit circle, which I know that's pretty exaggerated, but I think that'll help. If it's less than negative 1/2, I'm going to be below that because, sine is the vertical displacement. Okay, I tried to draw it so that they were both visible. Maybe that seems to do a little better. We're able to see that there's both colors there. And so I need to figure out what that point of intersection was. Well, this was where cosine x equal to 1/2. That's going to be definitely a tall 30, 60, 90 one with a 60-degree reference angle. So this would be negative pi over 3. That's like 5 pi over 3. And then up here, where sine x equals negative 1/2, that's almost all the way to 2 pi. That's going to be 11 pi over 6. And since these were both strict inequalities, I know x is going to be greater than 5 pi over 3 and also less than 11 pi over 6. Sine x less than negative 1/2. I feel like we did that one just a moment ago, but that's fine. I'm just going to kind of color on that. Sine x is less than negative 1/2. I'm below negative 1/2 vertically on the unit circle. And then cosine x horizontally, I'm less than root 2 over 2. Well, cosine equals root 2 over 2 at the 45s. So it'll be here and there. And, okay, if it's less than that, horizontally, I'll be to the left of that. Okay, now I'm going to start having solutions. Yes, solutions. Okay, there it is. So it's really going to be here to there. And so that looks like 7 pi divided by 6 up to, that was a pi over 4. That was a 45-degree angle, so almost all the way to 2 pi. 7 pi divided by 4. So 7 pi over 6 is less than x is less than 7 pi over 4. I actually really like these. I think these are good problems. All right, now this one, cosine's positive and sine's negative. Okay, I think we'll just do this one the same way we were doing the other ones with shading. But cosine's positive, that's going to be everything over here in the first and fourth quadrants. And sine is negative. Okay, well, that's everything in the third and fourth quadrants. So that's only going to be the fourth quadrant. And so that's going to be 3 pi over 2 less than x less than 2 pi. Okay, now I think the last set of problems we've got is going to be some applied problems. So we've got the average temperature in a city defined by f of t is 70 minus 40 cosine of 2 pi over 360 times t minus 15 in degrees, like degrees Fahrenheit. T days after January 1st. How many days is the temperature above 90 in a year? Okay, well, what we're going to do is I think what I'm going to suggest for like inequalities like this, it's already hard enough to solve these equations. 2 pi over 360 times t minus 15 is a lot. Let's just replace that with theta. So let theta equal that business. And so I'm going to rewrite this situation. I'm interested in where this is greater than 90. So I'm going to say 90. Oh, wait, hold on. Yeah, no, greater than 90. I'll fix that in a second. But I'm just going to kind of subtract. You can see I already wrote this out. And then, solve for cosine theta. And then I'll bring in a, unit circle diagram. But that one's actually not very good. I think I'll make a new one. All right, there we go. Because we want the average daily temperature to be above 90, greater than 90. And so I'm interested in where cosine theta is greater than negative 1/2. We can find where cosine theta equals negative 1/2 on the unit circle. That would be right here. It looks like 2 pi over 3. And down here at 4 pi over 3. All right, and so really I think what we might do, okay, it's like this. And I know this is not a very standard looking clock, but if you thought about this like in terms of the unit circle and said, all right, basically January 1st is going to be t equals 0, like theta equals 0, the beginning. Which really, I guess that might be a little confusing. Either way, I guess I could say negative pi over 3 or negative 2 pi over 3 to positive 2 pi over 3 might be a good way to go. Let me think about this for a second. Okay, yeah, there's a lot of things looking wrong about that to me, and I'm just now realizing I did a bunch of stuff wrong there. Most importantly, probably like that inequality. When I divided both sides by negative 40, I did not reverse the direction of the inequality. And so that's really going to help. Cosine theta is going to be, that makes more sense, right? Because there's like, it should be not that many days in the year where the average temperature is above 90 degrees. It'll be that cosine theta is less than negative 1/2, and that'll be between 2 pi over 3 and 4 pi over 3. So I was thinking, the season of being above 90 shouldn't be broken over the new year, or at least it doesn't seem like it. So what I'm going to do is I'm just going to figure out where theta equals 2 pi over 3 and theta equals 4 pi over 3. And then just figure out the distance between those two numbers of days. So theta equals 2 pi divided by 3. Okay, well that means that 2 pi over 360 times t minus 15 equals 2 pi divided by 3. Okay, well I think first thing I'm going to do is divide both sides by 2 pi. And then maybe multiply both sides by 360. So I'll have t minus 15 equals 360 divided by 3. Okay, that's funny that fraction showed up. That was one that y'all kind of struggled with on the free response. 36 divided by 3, you need to simplify that. Okay, well, 360 divided by 3, maybe I think it was 3 divided by 36. That'll be 120, and then I'm going to add 15 to that and get t equals 135. And that was like the beginning of the days where it's above 90 degrees, maybe the beginning of the summer. Okay, and then theta equals 4 pi over 3. That's going to give me 2 pi over 360 times t minus 15 equaling 4 pi over 3, yeah. Okay, so I'm going to divide both sides by 2 pi. We're left with 2/3. Okay, multiply by 360, so 2/3 of 360 will be 240. So t minus 15 equals 240. I'm going to add 15 to both sides, and I'll get t equaling 255. Okay, so that'll be from 135 to 255. That'll be for 120 days. Which, if you think about the actual distance between 2 pi over 3 and 4 pi over 3, that's 2 pi over 3, and that is a third of the circle, so it would be a third of the period, and we can see on the equation the period of this thing is 360. Okay, so that does make sense. All right, for this coastal city problem, max tide level or whatever, we're just going to do the same thing. We want to know when is the maximum tide level above 8 feet, so we're going to say 6 plus 4 sine of theta is greater than 8. Okay, or greater than equal. Greater than equal, that's fine. We'll just solve that one like that. And so I'm going to start by subtracting 6 and then dividing by 2. So sine of theta is greater than or equal to 1/2, and that's trig function equals number. That's something we can work with. Okay, so we're going to go over here and say sine equals 1/2. We've done that a few times today. Here, if sine is greater than or equal to that, that'll be up through here. So this corresponds to theta equals pi divided by 6. And this is theta equals 5 pi over 6. Okay, and then what was I thinking? Oh, okay, I probably should have written down what I meant by theta. So I'm going to say theta equals pi over 14. It's the inside of the sine, multiplied by t minus 2. Okay, so now that I've got these theta values, I've got what theta is actually representing, I should be able to solve for my t values. Okay, what time? Yeah, that's just going to be an interval. So it doesn't say like how many days. Is it above 8 feet? I think sometimes it's best we not think too deep on the actual meaning of these. Leave more confused than you were before. All right, so 5 pi over 6, that's my theta value. That's going to equal pi over 14 multiplied by t minus 2. So I think I'm going to multiply both sides by 14. 14 times 5 would be 50, and 20 is 70. Okay, also probably divide both sides by the pi. 70 over 6 equals... that's what that is, equals t minus 2. Okay, well, I can make that 35 over 3. Just either way, I don't think there's really a whole lot I can do. I'm going to have t equals, add 12 over 6 to both sides. That would be 82 over 6. But you know, this is AP Precalculus, so we do have to simplify our answers. That'll be 41/3. Okay, that's one of them. And then I'll do the other one. That's probably going to be the upper bound because I did 5 pi over 6 first. But pi over 6 equaling pi divided by 14 times t minus 2. Multiply both sides by 14, divide by pi. That'll be 14 over 6 equals t minus 2. I'm going to add 12 pi over 6 to both sides. And that would be 26 pi, or no, just 26 over 6. I don't know if I've been saying pi this whole time, I hope not. But 26 over 6 is going to be 13 over 3. So the kind of the time interval is 13/3 is less than t is less than 41/3. Okay, now the height of a carnival ride can be given by the function h of t is 35 minus 30 cosine of pi over 10t. And t is time in seconds after the ride starts. Okay, and how many seconds during the first revolution of the ride will the height be? There's something missing with this sentence. I don't know what it is, but when is the height going to be above 50? Okay, so 35 minus 30 cosine theta is greater than or equal to 50. And so then I'm going to subtract the 35 and have 15 left on the right side. And then this time I won't forget when I divide by negative 30, I'll need to reverse the direction of the inequality, and then I'll be trying to solve when is cosine of theta less than or equal to negative half, which I think we just did earlier on this page. Okay, but cosine is the horizontal displacement from the y-axis, and so negative a half, that's not that far. Over here, that's going to be 2 pi over 3. Over here, that'll be 4 pi over 3. When cosine is less than or equal to, I don't know why I keep saying or equal to. It said above, so I think that probably means strictly greater. Okay, but, and again, theta equals pi over 10t. This is going to be a little nicer to solve. So I'll say either 2 pi over 3 equals pi t over 10, or maybe 4 pi over 3 equals that. So we'll start by multiplying both sides by 10. So let's divide both sides by pi, and I'll get t is 20/3 and t is 40/3. So if they're asking how many seconds during the first revolution will the ride be above 50 feet, we're going to say, well, the amount of time is going to be 40 over 3 minus 20 over 3 equals 20 over 3 seconds. All right, that was pretty serious homework. That's going to be all for this video. Thanks for watching.